The recoiling gun compresses a spring of force constant K by a distance D. So what is happening? You have kind of a gun. And a bullet is fired from the gun. The mass of the gun is M. The mass of the, bullet is M, small m, and the mass of the gun is capital M. And this gun is recoiling. The gun is going back and compressing a spring, right? Of spring constant K. So first thing is you have to have a story made of what is the question. If you don't understand the question very well, you're not going to get an answer, right? Okay. So this is your understanding of the question. By a bleak chance that it is something else happened, your answer is not going to match. Okay. Then you have to rethink. Did I understand the question right or wrong? But first you have to understand the question right. Everybody got the question?
Yes, sir.
Yeah. So Avik, tell me. So what is the process? What you are going to do?
So we can do this one, linear momentum conservation.
Yeah. So what will you do? Tell me. Say the velocity of the bullet is v. So what are you going to do? Tell me.
So suppose like bullet is Q1 and one is Q2. So
Okay.
but the gun will be placed initially is Q2 will equal to 0. No, wait. So there are 1 minute.
Okay. So I'll make it for you. Suppose the bullet goes with small v forward and the gun goes with capital V backwards. That is what is going to happen, right? Before it compresses the spring, right?
Yeah. Yes,
Right? Look up on the board. The bullet goes with small v forward and the gun goes with capital V backwards. So for this, what equation are you going to write?
Yes, sir.
What's the equation?
So small v minus capital M capital V.
Yeah, correct. Is equal to how much?
Yes, sir. I'm doing that.
So mv is equal to mv, right? Initial net momentum was 0, right?
Yeah.
So small v minus capital M capital V is equal to 0.
Yeah.
Then what is the other thing, other part? With so much of energy, the gun is going backwards and then it stops. It compresses the spring and stops, right?
Yeah.
And the velocity becomes 0, right? So what equation will you write for that?
Energy conservation.
Yeah, so what is that?
So initial kinetic energy will be equal to the final potential energy.
Now speak out the equation.
I said half m, the velocity of your square equals to half k d square population I've taken as d and this is constant as k.
Yeah, but who is speaking? Raise your hand. Okay. Right?
Yes, sir. And so we can get the value of v from
Yeah,
the
so you get your V from here and put that V in the above equation and you get your answer, right?
Yes, sir.
I really wonder why you could not do the question. So the most probable cause will be you're not understanding what the question means. Okay, so that's the key in any physics question. Is that clear?
Yes, sir. Yes, sir.
Any other doubt? Any other page? Any other doubt? Any other page? Shall we go ahead then?
Yes, sir.
A man of mass M is standing on a platform. I'll tell you the question. Guys, can you see my writing at least?
Yeah. Yes, sir. Yes, sir.
So this is a platform. Okay.
Yes, sir.
And there's a man of mass M.
Yes, sir.
Moving on the platform with a speed V
Yes, sir.
is equal to velocity of the man with respect to the platform.
Yes, sir.
With what velocity relative to the ice does the platform recoil?
We take the masses as capital and as small.
So mass.
Yeah, tell me, Vishwagna, what to write.
So masses. So what are the masses?
Capital M of the platform, small m of the man. Not impressive at all.
No, it's
Not
not.
impressive at all.
Sir, I didn't see the question.
I made the man, I made the platform. It would have taken me more than a minute. In that much time, you could not gather the question. Is not impressive at all. That is the sign of people who cannot do questions, who don't understand questions. You have to understand from text. Here I have made a diagram for you.
Sir, can you give me a minute? Sir?
Okay.
Yes, sir.
Everybody has done it, right? I hope the books are closed. Everybody has done it at the home, right?
Yes, sir.
Raise your hand who can do it again over here right now. Who has got an answer? Only 3. That's not a good way of studying. 3 names again. Tell me the 3 hands raised. Name क्या है? न से क्या नाम है?
Ahan.
Ahan.
Yes. Nivan.
Ahan, Nivan, and
The Arsh.
huh?
Arsh.
Arsh.
ARSH, yes, sir.
Sir, is it NV by N? Small m, V by N.
Yep.
Yeah,
No.
small. No.
What is the equation? Tell me the equation.
Sir, so first, the velocity of the man with respect to the platform is V. And sir,
Yeah, okay. Keep speaking.
sir, Vishwagna.
Yeah, speaking. Keep speaking.
Yes, sir. So the velocity of the man with respect to the platform is V. And the mass of the man is M, mass of the platform is M. So since the platform is at rest initially and the man is moving, I try to conserve energy and conserve linear momentum since there are no external forces.
Initially, both are at rest, okay? Just to correct you, since the platform is at rest, initially is not the statement. Initially, both are at rest. The man is standing on the platform, kept on a smooth ice. Kept implies it is at rest, and man standing implies it is rest. उसके बाद है the man starts moving. Starts means then he moves, okay? That's the normal meaning. Pretty normal English. Yeah, okay, tell me.
Sir, I couldn't read the question. So if the man isn't moving, then if I take in your diagram, if I take left side as positive, then
Okay.
0 equal to mv, my small m into small v, minus capital M into capital V.
So this is wrong. Now tell me why it is wrong. The ones who have not done it at home and wants to do it right now. Yes, who will tell why it is wrong?
So you have to take the velocity of man relative to the
Platform.
not relative to the platform.
Who is telling this?
Ahan.
Not Ahan. The three people who have done should not be speaking. The ones who have not done should be speaking. So I really wonder, this was the easiest of the three questions which I see over here. 19, 20 based on the same concept. 21 based on the same concept, not 21, but 22 based on a similar concept. And 24 based on the same concept. Like 24 is the higher version of what we have just done. So how did you manage to do all these questions if you could not do the first one?
Sir, I don't know. Maybe I got the wrong answer. I didn't check my answers.
No, I'll tell you why, and you have to believe why. You have somehow got the answer stumbling upon it, and it has not come from within you. You have read the question, could not get the answer yourself, then read the answer and thought you have understood the answer. If you keep doing that way, you're not going to learn much. You will get stuck and you will always wonder why you're stuck and not scoring high. How you learn the questions is very, very personal. Only you can monitor yourself, and how you are doing is very, very important. If you do in a way which is not sustainable, it is not good. Now, Vishwa, question number 17. I don't know whether it is visible or not.
Sir, it's
Is it
visible, right?
visible?
Yes, sir.
Yeah. If you can do question number 17, you would be able to do the board question and all. So all of them are related. I will do any one. Yeah, this is also a similar question. Acha, this is the one I gave, right? So when the speed of man is with respect to the boat, as soon as the man starts walking, the platform has got a certain velocity. Say capital V is the velocity of the platform. So what is the velocity of the man? Say in your head, you will say a number. Say V is going back with 1 meter per second. Man with respect to the platform is going with say 3 meter per second. With respect to somebody who's observing from outside, what do you think? What is he seeing?
The man going with 2 meters per second.
2 meters per second, right? So you'll think of some numbers and then you'll make an equation which convinces you. So the velocity of the man with respect to ground is what you have to write. So velocity of the man with respect to ground must be how much?
V, small v minus capital V.
Yes. V minus capital V, right? Which
Yes,
way?
sir.
Left side, okay? Okay. And hence the equation is mv minus v minus mv or is equal to capital M into V, right? This is the correct equation. Is that clear? And that's the
Yes,
answer.
sir.
Like you have to just write so much and you'll get the answer. So now I'm not being very critical, but I'm saying that if you have not done this properly, you have missed the whole point. This is the point of the example question, to build you on this very small concept that when somebody is walking on the velocity to ground, the term.
Sir, your voice
Sir, your
is
voice
I'm
is
not going to
breaking.
waste opportunity of learning. Okay, everybody got the point?
Yes, sir.
Yeah, so please do, the ones who have not done it properly, please do these questions much more closely. And if you don't get an answer, like if I have to do question number 22, I would be hiding the answer. Even the first line, let the velocity, I should not see that line. I see the line, I lost my opportunity of learning. So when I say do the homework, it is not just to show me, just not to avoid the scolding from me. It is to actually learn, because if you actually don't learn, your marks will not come in the exam. If your marks will not come, you can make a lovely story in your house that I could not understand, or I did not got the point of time to study, or this or that. Whatever story you make, the bottom line remains that in the competitive exam, you will not be able to beat the others and you will not end up in a good college like a IIT or a NIT. That remains the bottom line because of whatever were the circumstances. Is that clear? Is that clear, guys?
Yes, sir.
What are you guys talking at the end, guys? Okay. Any doubt? Now, Vishwa, since you have come for the class, which is like a remarkable thing with to your other mates not turned up for the class, okay? Looking at the state of condition, I will explain you the last answer before going ahead. But this is not acceptable from next class onwards.
Yes.
This is a boat on which there is a man walks towards the jetty. I'll not make the girlfriend standing over here. Okay, I'll just say the point G where the girl was. Okay. Mass of the boat. Yellow is the boat, like the plank was yellow in last question. Mass of the boat is M. Mass of the man is small m. Center of mass of the boat, I said you can take any which place. But now just for making you understand, I'm taking boat. Okay. And if you become cool in the concept, you'll not take it at the center of the boat. You may take it under the man. Okay. So that is small details which you try to understand from your friends. So this is your man. And I will take a reference axis. This is my reference axis. And I'll try to find the location of the center of mass. So what is the location of the center of mass? Tell me, Vishwa, what equation shall I write?
Sir, m into m plus x, mx form equals m into L, where L is the length of the boat.
Okay.
Plus capital M into whatever the distance between the axis and the L by 2. Yeah.
Yeah. Okay. Now, okay, after some time, what would have happened? And the man here, right? Right?
So your voice is still breaking, we can't hear you.
Now, is this XCM and that XCM, is this XCM and this XCM different?
No, sir, it's the same because there will no net external forces.
Yeah, so it is somewhere over here and remains over there. Okay.
Yes, sir, I understood how to do it from here.
So equate first and second and you'll get your answer of the D. Is that clear?
Yes, sir.
Then you can do some variations. Instead of L by 2, you take it anything in this world and still it will work. Okay. If you take Y, the Y will get cancelled. Can you see that the Y will get cancelled, right?
Yes, sir.
So we did some variations in the class. We said, okay, why not the center of mass of the boat is here itself? Still the answer is same. Is that clear?
Yes, sir. I remember.
Is that clear? Then we did one more variation. And what was that variation? Can anybody tell me what was the other variation? We claimed how much is the center of mass this side of the boat. Later on, it would be that side of the boat, right?
Yes, sir.
Just by the symmetry of it, right?
Yes, sir.
So we found out where the center of mass is. So alternate method. Where the center of mass? We'll say capital M into the small x is equal to small m into L by 2 minus x, right?
Yes, sir.
Right?
Yes, sir. Yes.
And we found the x using this, which is how much? Which is x is equal to small m into L by 2 divided by m plus m, right?
Yes, sir. Yes.
And we said double of this is the answer, right?
Yes, sir.
So that was little quick. Now here we use our variation on variation that we claim that the mass is just below it, right?
Yes, sir.
right? So if the m moves, say x amount, this will move how much?
The same X.
Not same x, m by m plus x, right?
If what
And with that also we did it. Okay, so we did some variations, that is last class, but any which way, this is the most basic way of doing it,
Yes,
taking axis outside and doing it, right, Vishwa?
yes, sir.
Now the very same thing was explained in the class using double or triple the time. I wonder why did you not gather it that time and why you are saying yes now? So I wonder means you should wonder what is the difference? Your attention span, your attention like intent of learning that time, what is the difference? So what's the guarantee that you now you say yes and after 1 week you have again not forgotten about it? What's the guarantee? So what you should be doing for that? So you ask these things to yourself and continue studying, okay?
Yes, sir.
Okay, shall we go ahead with the concepts, guys?
Yes, yes, sir. Yeah.
Okay. So I'll do 1 or 2 questions with the relative velocity concept. Okay. Example 24, guys, please do at home. Okay. Yourself, don't look at the answer. Please do at home yourself. Is that clear?
Yes, sir.
What is typically happening in this bullet kind of question, guys? What is happening in the bullet kind of question?
First, we can use momentum conservation to find the
Yeah, the bullet strikes the mass.
yeah.
At this time, when the bullet strikes the mass, energy is not conserved. Energy is not conserved, okay, but momentum is conserved, right?
Yes.
Whether energy is getting conserved or not, momentum is conserved. So we don't imagine the spring to be compressing before the compression happens. At the instance of at the instant, like before and after the instant of striking, we write the momentum conservation. So before that is mv naught, and afterwards is maybe the bullet has gone into the block and is sticking in the block and gets a velocity v, right?
Yes, sir.
So once the body with the bullet gets the velocity of v, what do we know do next? Now we can conserve energy. Now we can conserve energy, right? So this is a very, very, I think, I mean, very common way of putting the question. Conserve momentum, then conserve energy. So get into the habit of that. This is again a good question of your understanding the relative velocity properly. So momentum is being conserved in the horizontal direction. So what is the horizontal velocity of the block? What is the horizontal velocity of the block on the wedge? With respect to wedge is u cos theta, but with respect to ground would be u cos theta minus v, right?
Yeah.
So the block is going with u cos theta minus v. Okay, so that is what will be written for the block. Okay, is that clear?
Yes, sir.
So
Yeah, in the horizontal direction. And you have to conserve the momentum in the horizontal. So this very simple equation will come that capital M into V, the wedge going one way, is equal to mass small m into u cos theta minus V going the other way. In one go, you'll be able to write it, right? Now, since I have spoken it, I have done a crime. You have lost the opportunity to learn yourself very well the same thing. You have to self-learn, then only you'll crack any IIT. I'm not saying IIT Bombay and all. Any IIT, getting a 5,000 rank, 7,000 rank, and getting into a decent IIT, you have to self-learn. Don't wait for the teacher to make you learn. Is that clear, guys?
Yes, sir.
Yeah. So there are a bunch of questions on spring block system. We'll straight away take up the question and start doing it. Okay. Everybody, give it a go. Okay, done. How many are done?
not yet.
Huh?
So not yet.
How much time? You're on to something or you want me to do it?
So just give us a
So
few moments.
a few moments, yes.
Yeah, shall we, guys? Done? More time?
So could you show the options, please?
No,
We don't have options.
Oh, there were-
no, I hid the options purposefully. By mistake, I was showing it earlier. Yeah, done, guys.
So I got √3/4 meters. I got 18.6 plus 5. So is it √3/4 meters?
I don't know. Who is speaking? Name? Yeah, I don't know. Okay. So let's see. So first you have to have something in your head that this is how we are going to solve it. If you don't have a plan, don't start working on the question. It is a absolute waste of time. You start writing something. In maths, you don't know how to conclude a question. You know how to just to begin, and you write, and the things follow. But in physics, that is not the case. Okay. In maths, you should get into the question, keep writing, and the things will unfold. Not in physics. In physics, you should know what you are going to do. Then only you write even the first line. Is that clear? In 2-3 lines, it is done. The question is done. But you should know, you should have a thought process. So what is happening? There are 2 blocks kept. They were stationary. The spring was having no extension in it, right? And then somebody imparted velocity to both of it together, right?
Yes.
Is that clear?
Yes.
Yes.
And they're asking what is the maximum extension? Yeah. So I think you would have done some questions where maximum or minimum separation in kinematics, you would have done that. So what is the critical point you are going to attack in this question? What is it? Maximum extension ke liye, what are you going to do?
So when kinetic energy is
Yeah.
0, then it will be at maximum.
And kinetic energy is 0. No, that's not the way of
And one of the
thinking
blocks,
or putting.
if one of the blocks is at rest, then that's before it will gain velocity and start heading towards the other block.
No.
It's okay. Can we take it from the
So let us
frame of
just
reference
discuss.
of one of the
He says, somebody said that when one of the block is at rest, which block you are assuming? Who said that?
Nivan?
Nivan.
Yes.
Yeah, which block you are assuming will come to rest?
So it can be the 3 kg.
Huh?
So it can be the 3 kg ones.
3 kg. Yeah, why do you say that?
Sir, because it has a lower velocity and a lower mass, and the force given by the spring on both will be the same. So
Yeah, it looks like A will come to rest first. Okay. I'm just discussing his thought. Okay. We are not even going to approach the question this way, perhaps. Okay. Let us see what he's thinking. So A has got a momentum of how much? 3 into 1.8, right?
Yeah.
B has got a momentum of how much?
13.2.
6 into
6
2.
into 2.2, right? 0 time wasted in doing the calculation, okay? Of how much it is. Why? Because you have to use it. Perhaps later you are getting 2 cells is happening. You be dividing a 13.2 or you will be cancelling over here. Suppose you are dividing by 3, you will not be multiplying. Why? You are not going to increase your own hassle. Okay? There is joy in doing a math of multiplication and division. Okay, so forget about those days whether multiplication or division is an issue. Okay, so I was saying that the momentums are 3 into 1.8, 6 into 2.2, right?
Yes, sir.
Force acting at any time on both of it will be same or different. What do you think? Which will experience more force? Body A or body B?
Neither.
It will be the same force.
It will be the same force because the spring, if it is extended by X, okay, then it pulls both the ends by how much? Kx, right? Right? It
Yes.
doesn't matter you extended the spring from left side or right side, it doesn't matter, right?
Yes.
Is that clear? There is no memory in the string that it got extended from this side or that side. Is that clear, guys?
Yes.
So if the force acting is same, then obviously the momentum, which was less, is going to go to zero first, right?
Yes.
So Nivan was saying that this reaches zero momentum and the other body. So this A block has stopped. We are going to see why he is wrong, okay? Maybe he tells why he's wrong. Maybe you tell why he's wrong. And the spring is having certain extension. At this moment, will the other body have some velocity or no velocity? We just now discussed that it will still have some velocity, right?
Yes.
Yeah.
Yeah. And
And this has become V is equal to zero velocity, right?
Yeah.
So does it look like that this is a situation when the spring is maximum extended?
No.
No, right? Because if this has got a velocity, it is going to extend the spring even more, right?
Right.
Yes.
So both have to be.
Right? So
Yeah.
Nivan thought that now this will start following up and hence the extension will become less. But yeah, it will start following. A will start following with a much lesser velocity now, say 0.01, and this is already having some good velocity, say 0.5 or whatever. I've not calculated. Okay.
Yes, sir.
And it is not like at this time the spring has started compressing when this has wanting to compress the spring. So Nivan's thought was A is wanting to compress the spring, hence the spring is compressing. Is not a complete thought because B still is big time wanting to extend the spring, right?
Yes, sir.
Right? So having a wrong thought is nothing, like there's no wrong in it. You have to think about it. It's a good thing that you have thought about the situation, but you have to think it through fully and completely and reject your own claim. Okay.
Yes, sir.
The day you reach to that point that you are rejecting your own proposition is a good time. Okay. You may not come to the right one, but you know what is wrong is a good thing. Is that clear?
Yes, sir.
Not knowing that this is wrong and completing the answer with this is a big blunder. Knowing this is wrong, knowing where you are wrong is like you are on the right track, an absolutely right track. Okay.
Yes.
So anybody else propose when to get the maximum extension?
So can I tell?
When should it happen? Raise your hand. Ahan, right?
Yes, sir.
Yeah, Ahan, tell me.
I tried looking at it from the frame of reference of one of the blocks. So I took the frame of reference of A. So the point at which so the velocity of V with respect to A is now 4 meters per second. So when the velocity of V with respect to A reaches zero, then it will be at maximum extension.
Yeah, that looks right. So continuing on that thought, good, Ahan. Okay, so absolutely right, very well said. I don't have to explain it by going to on the reference frame of A, but whatever looks comfortable to you in your thought process, go ahead with it. Okay, no problem at all. Okay, now continuing with what Nivan said, A has become zero velocity, A has reached zero velocity, and B is still having some velocity. It is quite kind of futile calculating that velocity for this question, but if you wish, you can calculate. Can anybody tell me this velocity, intermediate velocity, need not be calculated, but just for we are in the learning stage, right? Exploring the question big time, right? So
Yes.
what's the velocity this way? I'll quickly write it, okay? Assuming right side to be positive, it is -3 into 1.8 plus 6 into 2.2 must be equal to how much? 6 into this velocity, what we are wanting to find, right?
Yes, sir.
Is that clear?
Yes, sir.
See how cool it is, not actually multiplying a 6 into 2.2. Look on the board how good and useful it is for me. V dash is equal to, I divide with 6. So what do I get?
Minus
2.2 minus the
0.9.
3 by 6 is a, yeah, half. So it is 0.9 and which is a
1.3.
1.3, right? So
Yes,
we
sir.
get that this is traveling with 1.3 meter per second. Mind you, need not be calculated. If you have a good conviction that it is still going with a good velocity, good enough for us. Is that clear? Now what is going to happen? Now A is going to increase in velocity, and what is going to happen to V dash? V dash is going to decrease in velocity, okay? The reason is the total momentum has to be same. The other reason is the spring is now having a good stretch, not the maximum, but a good stretch, is pulling the A and it is pulling the B, right? Pulling the A is going to increase the velocity and pulling the B is going to decrease the velocity, right? Is that clear? I'll not draw these arrows so that I don't get confused and I just look at it like this. So while V dash is still higher than VA, VB is still higher than VA, what do you think? The gap will be increasing or decreasing? I'll again repeat.
Decreasing.
While VB is still higher than VA, the gap will be increasing or decreasing?
Increasing.
Huh?
Decreasing.
Oh my God, I can't make out it is
Increasing.
The gap between.
going up or going down?
No,
Increasing.
I thought you meant the gap between their velocities.
Gap between the velocity. Kill yourself, man. Oh my God, am I on record? I didn't say that. There was somebody else who is behind me. Somebody else said that. Oh no, it's really on record, no? See. Good thought process, okay? Nothing wrong in the thought process, okay? Good for trying, but absolutely wrong, okay? Whoever it was.
Yes, sir.
Absolutely wrong. If this VB's velocity is more than VA velocity, obviously the gap is increasing, right?
Yes.
Right? Imagine somebody is running ahead of you. You are having a lower velocity. The man ahead of you is having a higher velocity. Is the gap increasing or decreasing? The gap is increasing, right?
Yes, sir.
Now the guy who is ahead of you, it's kind of a marathon race. The guy who is ahead of you is now slowing down a bit and you are increasing your speed. When do you think the gap stops increasing?
When you both, when the speeds are equal.
Yeah, when you reach the same speed, right? So this thought is such a common thing in so many physics questions. So we might have taken some 5-10 minutes to derive to this point, but this would be like any other person knows this, okay? What? When the speed becomes same, then is the time of your maximum extension or compression. Okay, the gaps are minimum or maximum at those times. Those are the critical times to think about. When the speeds are same, not when one velocity is 0 and the other velocity is not. Is that clear? Now do the question very fast. I see 2-3 people onto the question now and others are just rolling their pens. Please do the question now. This is the only thought what had to come. What was it? The extension will be maximum when the speeds are, when the velocities are same. Okay, that's the critical thought which had to come. So a good way of doing will be what? First find out the speed. So what would be the first thing to find out? What is that velocity when the velocities are same, right? What is the velocity? So what will you do to find out that velocity?
Conservation of momentum.
Conservation of momentum, right? Yeah. Yes, guys, how many got the answer now? How many got the answer? Are you listening?
Yes.
Yes, sir.
Sir, 1 second.
Yeah, got the answer?
No, sir, 1 second.
Shouldn't be taking so much time. Okay, look on the board now then.
62 by 16 root 2.
How much?
62 by 16 root 2.
I don't know. Let's see. So one is, what's the initial momentum, guys? Say momentum towards the right is the positive momentum. We see that momentum towards the right is positive, right?
Yes.
So initial momentum is 6 into 2.2 minus 3 into 1.8 is equal to the momentum when the velocities become same, right?
Yes.
Yes.
Yeah, equal to, yes, say the velocity is, say V. Is that okay?
Yes.
Is equal to how much?
And
MV plus MV, right? So shall I write M plus MV?
yes.
Yes, sir.
3 plus 6V. So we get a V straight away from here, right?
Yeah.
That's your first equation. And I don't even qualify it as an equation because straight away we are getting the answer. I mean, I don't have to label it as one. So how much is V? I hope everybody has calculated. How much is that?
13 by 15.
13 by
15.
13 by
15.
13 by 15, you say. Shall I believe or shall we do quickly? So here it's a 6 common. If I take, it is a 2.2 minus 0.9, right?
By hand.
So that's a 6 into 1.3 divided by a 9, right?
Yes, sir.
Yeah. So it is a 2.6 divided by 3, right?
Yes.
So 26 by 30, you said what? Who said what?
13
13
by
by 15. Yeah. So we got this velocity. Now, how to know the extension at this velocity?
So we
Okay.
conserve energy.
Yeah.
Yeah. So who will tell the energy equation very fast and I'll just write it? Just after the impulse. Okay. At the impulse, energy is not conserved. It got velocity from God knows who. Okay. Then just after the impulse, how much is the energy? Who will
So,
speak?
Vishwagna.
Yeah, Vishwa bolo. Half.
So half into 3 into we can take the v square common if you like. So
What v square common? Please
the
don't do that, man. Just speak out the whole thing.
yes, so
Yeah,
half.
half into 3 into.
So but shouldn't we take 13 by 15 as the velocity? At the
You're
end?
saying the final or the initial? What are you saying?
The extent we need the extension, right? When VA equals VB.
Yeah, okay. Tell me what you want to say. Then we'll write. Then we'll debate. Yeah, half into what? 3 plus 6 you want to say?
Yes, sir.
Yeah, okay.
Half into 3 plus 6 into v square, which is 13 by 15 whole square, plus half into 3 into 1.8 plus half into 6 into 2.2 equals
Half into 3 into 1.8 square.
yeah,
Square,
1.8
no?
square
Okay.
plus half into 6 into 2.2 square
Yeah.
equals half into 512 into d square.
Now, can you speak out in English what it is?
Sorry?
Can you speak out this line in English what it is? In language, what is this line?
So conservation.
Total energy after the spring has extended, total kinetic energy after the spring has extended, plus the kinetic energy what the bodies were having before the spring extended is equal to the spring energy is what you have written, which doesn't make any sense. Like, what is this? I don't know. You have just connected some things. See, what is the energy? Since you have written final first, I'll just write fine. No, I सब कुछ तो मिक्स ही लिखा हुआ है. What is the initial energy and what is the final energy? Without knowing what was the history and what is going to happen. Without knowing what has already happened and what is going to happen. At this very snapshot, what do you see? The energy is the energy at that instance. Okay. So at this snapshot, when the body was just put into motion, I don't know how much it is going to extend and all. I don't care. How much is the energy at this moment? This is called initial energy. What's the energy at this moment? Yeah, Vishwa?
So the second half of the left hand side.
No, only this is that energy
Yeah.
at that moment. Only this much. Okay. Now, when the spring has extended and both the body have reached the same velocity, if you wish, you can make a drawing for yourself. Both of them have reached how much velocity? V velocity. And the spring has extended by x. What is the energy at this moment? I don't even care what happened earlier and all. At this moment, what is the energy?
Half into 9 into 13 by 15 squared plus half kx squared.
Yeah.
Yes, sir.
So also that should be a 2.
And these two should be same, right?
So should it not be?
Ayo.
So that should be a 2
Two.
into half.
1 second. 1 second. 1 second.
Both of them.
Yeah, both systems have the force. That makes sense.
So you had to equate this, right? At least you have to write this. You had all the components, but here and there.
Yes,
That's not correct.
yes, sir.
ठीक है?
Yes, sir.
Yeah. Who was saying what? Any issue? Any doubt?
So I thought it would be 2 into half kx. Both bodies.
1 second. Let me make 2 into half kx. What is 2 into half kx square? What is that?
Because each body has potential energy.
Each body has potential. No, the spring without the body attached to the end, the spring is having so much of energy stored in it. Is that clear?
Yes.
We have done work on the spring, and the spring has got a certain extension to it. Okay,
Yes.
the bodies don't have this energy. The spring has this energy. Got the point?
Yes. Sir.
And the spring has a total extension of x, so the energy is half kx square. Okay. Okay.
Yes. Sir.
Now I think we have 0 variables in it and just the x. So I'll again not label the equation as equation 2, and we'll just straight away find the x, right?
Yes.
All values are given, and whatever is the answer is the answer. Is that clear? Is that clear?
Yes.
Yes, sir.
So now they have bunch of problems. I did the first one, bunch of problems on spring. Try to understand each of them yourself. And 1 hour, I'm going to take doubts or half an hour or whatever on this spring part. But it has to come from you, the doubt. Is that clear?
Yes, sir. So
On
back-
Tuesday.
Okay.
On
Yes, sir.
Tuesday, we'll start with this. Okay, this is our lecture today. So spring energy based questions. When is their maximum compression, guys? Again, when they reach same velocities.
Velocity.
Okay. If any one has got any velocity with respect to other, that means the length of the spring is changing at that time. Is that clear?
yes, sir.
Is that clear? Okay.
Yes.
So looking at their answer, it is a 25 centimeter, but you guys do yourself. Okay.
Yes. Sir.
What's the micro?
I'll read one more question, but I'll not do the question. Let's just read this question number 27. A block of mass m is connected to another block of mass m by a massless spring of spring constant k. The blocks are kept on a smooth horizontal plane at rest. The spring is unstretched when a constant force F starts acting on the block. Okay, nice question. Constant force F. Okay. To pull it, find the maximum extension of the spring. So anybody, any idea what are you going to do? Can you conserve momentum?
No,
No.
Why? Because there is a external
external
force, right? Right?
Yeah.
Yes.
Yeah. So I will not do it for you, but give me some thoughts how we are going to approach it.
Find it.
So the accelerations of both the blocks, can be the same.
Same, yeah.
Otherwise, there will be some changing in the length. So you can try writing out the sum of all forces and MA.
What? Clearly and loudly, I could not make out anything. Tell me.
So for the spring to be at maximum, the
Yeah,
acceleration,
I can hear. Huh?
the accelerations of both the blocks will have to be like the same. Otherwise, it will keep changing. The accelerations of block to block. So we write out the force equations, and from there we equate the acceleration.
And why do you say so?
Sir,
Let-
because
Let me just make some question. You may be right, you may be wrong. Okay. Say this is a certain block going with 4 meters per second. This is another block going with, say, 1 meter per second. Is that clear?
yes,
Say both their accelerations are 2 meters per second square.
okay.
2 meter per second square, right?
Yes.
I think this is what you're saying. Na? Both their acceleration is same, then something, something. Now, if the acceleration is same, is the distance between them going to remain the same, whatever is the distance right now? Say the distance between them is d.
So here,
No.
because they have initial velocity. Yeah. Here they have.
Yeah, so when they will have the same accelerations, are they having same acceleration all the time, both the bodies? In that question? No, right?
No.
The first one is having the force on it, so it will start accelerating. The other one
Then the other
will
one
have a lesser initially, right?
Yes.
I mean, in fact, zero initially. So acceleration are not same, right? When initially accelerations are not same, after some time, what is going to happen? They will have different velocities, right? So hence I have given you a question: when two bodies are different, having different velocities, and their accelerations are same, do I claim that the distance is going to remain the same maximum or minimum at this point? No, it is not, right?
No.
Yeah. So forming a thought is nothing wrong, okay? Then you have to be critical of your own thought. Am I right? So proving yourself wrong, okay? This is how the scientists used to work 100 years, 200 years back, and still now. Prove yourself to be wrong, okay?
Yes.
Get the point? And you cannot prove yourself to be wrong, then you have the hooray moment that, okay, I'm right. But don't somehow make yourself right, okay? So this may come as the situation for you. I'm not negating it, but you have to like completely go through what you are saying. What you said right now is incorrect. Coming back to the question. So this is how you engage. Why am I reading it? I should not even read the little down line. Okay, there's some acceleration written over here that may have driven your thoughts. But by mistake, if you are seeing it, you should have just covered it. And you think. Nothing occurs to you for 5-10 minutes. You read a little, then think and do, right? That is how you digest a concept. Get the point? Versus you saw the question, you say, oh my God, how to do, what to do, I don't know. After 1 minute, you give up after 1 minute, and you look at the answer, and then you understand what they have done, and you say, I've understood, is having how much of value? Zero value with respect to good entrance exams. Zero value. I understood what they solved is having how much of value? Zero value. Is that clear?
Yes.
Students of your age or the ones who are in 11th and 12th are expected to understand. What is not expected is they coming to the conclusion and the answer themselves without help. Okay? Is that clear? So you have to train your mind and body for it. How do you train? There's so many examples. Don't keep reading the question and the answer and the question and the answer. How much ever frustrating it is for you. How much ever you think that I can't do it, how can I do? I don't know the concept. How can I do? I learn this one and then I do the next one. These are all common thoughts of very, very common people. You have to become uncommon by training yourself. Okay. Nobody can go into your brain and train you. Is that clear?
Yes.
Not your mom, not your dad, not the teacher. Nobody will know how you are learning. Only you will know how you are learning. If you are learning it the right way, there is no doubt that you will actually get it. Okay? It will be a difficult path, but you'll get it. Okay. Those who are naturally little bit having a flair and talent for this will get faster. Those who don't have a natural flair will get it slower. But eventually everybody will get it if you are doing it the right way. If you are doing it the wrong way, you will never get it. Okay. Chalo, so do all the questions and I'll spend, I said 1 hour on what? 27, 28, 29, hardly only 2 questions, only 3 questions. And I'm willing to spend 1 hour on it. But my end of the deal is don't look at the answer, okay? Till you have given good amount of thought whether answer is coming or not coming for you. Is that clear?
Yes, sir.
So paper se cover karna, okay? Learn properly. Our next concept is the last concept for today is impulse. Anybody? What's impulse?
So the force that acts for a very
Change
That's
in
an
momentum.
impulsive.
Change in momentum.
Impulse is change in momentum.
Yeah. चलो ठीक है कुछ impulse के questions कर लेंगे. Page 97 हाँ.
So but Tuesday.
Yeah, any other homework I've given for Tuesday? Nothing else, right?
No, sir.
No, sir.
Yeah, all the other homework was old thing, right?
Yes, sir.
Yeah. Three examples. Three examples are only there. Okay. Now comes impulse. Yeah. So we have been doing momentum conservation. When one body goes and strikes the other body, say this was having u1 velocity, this is u2, this is m1 mass, this is m2 mass. We have already derived initially in a class the law of conservation using the third law, right? Newton's third law
Yes, sir. Yes, sir.
of action and reaction. So when they have come in contact, when this body has gone on to strike this body, what happens at that time?
No,
Equal and opposite force.
Yeah. Yeah. So this receives a force, big time force, this way, and the other body will receive a force in the forward direction, right?
Yes.
Is the force constant? No, the force is not constant. As the deformation keeps on increasing while they are impacting, the force keeps on growing and then the body starts reforming. If you can see my hand, they impacted and it is deforming, the force increases,
that's the
fully deforms, and then force starts decreasing while it is reforming and then they go away.
just view.
Is that clear?
Sir, we couldn't see you.
Okay, say these are the two bodies. They come, they collide. As soon as the collision started, there is some small force and the body starts deforming. The force keeps on increasing, and the body badly deforms. There's a maximum force. Okay. And the
Yeah.
body forms reforming. It reforms. The force decreases and they separate out, right?
Yes.
Is that clear?
Yes.
So if it was elastic collision, we have done that. The velocity of approach is equal to the velocity of separation, right? Okay, so this force, if it is happening on a very small amount of time, say delta t time, we can graph the force. I think we have drawn a small graph also, right?
Yes.
Yes.
The force grows and the force grows back. Okay. If the formation and deformation are symmetric, then the force will also have a symmetric graph, otherwise not. Okay. Nevertheless, at maximum deformation, it will reach the peak. So that's the force and that's the time. Okay. Right. What will the area under the graph give? We have already discussed. So I'm just going it very fast with this. What is the area under the graph?
The impulse.
F dot dt. What will this give?
The change in momentum.
Change in momentum, right? That much is the momentum provided to M2 mass. That much is the loss in momentum of the M1 mass, right?
Yes.
Right. So we had written a plus and a minus. So I'm avoiding everything. I'll just write a delta P and not a plus and a minus. I will just say M1 momentum, M1 V1 will be equal to M1 U1 minus delta P, where delta P is this. And this guy will be how much? M2 V2 will be how much?
M2 U2 minus delta P. Yeah.
Say properly.
So M2 U2 minus delta P.
No. Think
Plus-
and say.
Plus that.
Yeah, sorry, plus delta P.
It was already going with U2, right? It received a impulse from the back and M2 U2 have this delta P added to it, right? So how much of momentum is removed from one body, that much momentum is added to the other body, and that was the, therefore the total momentum remained same, right? If you add the two equations, the total momentum remains same because of this fact, right? Right? Yeah, nothing in it because you have already done it. You want any explanation on it? I can still explain, but you have to ask for it.
So can
Okay, guys.
Yes, sir.
Yes, sir.
yes, sir.
Yeah. So sometimes solving some of the questions in terms of impulse is much easier than the other way. Okay, which kind of questions? And some of the questions, particularly related with bodies attached with a thread and all, there is a big issue. Okay, and I'll discuss the issue whether the questions themselves are valid. A good chunk of the questions are in the zone of being invalid questions, but in JEE they are getting entertained and those questions are still there. And we are learning with respect to JEE, so we'll learn those. Okay. Okay. Okay.
Yes.
Let me do a problem straight away. We have just 10 minutes, right? Let me do a problem. Or let me pick a example from your. Yeah. So we'll do this. Okay. Can you see the question, guys?
Yes, sir.
Yeah. Try to do it yourself. I'll give you 5 minutes, and in the next 5 minutes, I'll try to solve it. So get on very fast with it.
Sir, is it just B by 2?
No, you can't do that because tension will also be involved.
Why would tension be involved?
Because this is always moving downwards. So
Is
tension
it
will-
V by 2N?
Okay. The string will pass the impulse what it receives. If I pull a string with a certain impulse,
means tension
it
will-
pulls the other end with the same impulse. Okay. The rate at which the tension will grow and go down, T dot dt on one end, T dot dt graph on one end will be same as the T dot dt graph on the other end, T versus time, tension versus time graph. Okay.
Yes, sir. So we can take the full system to try and conserve that.
Shall I give you time or shall we do it now?
We can do it now.
Yeah. Sir, so since tension will act impulsively on either object separately, we can try taking the full system and writing momentum across the full.
All three masks.
Yeah, everything at once.
Okay, I'll do the way we should be thinking about it. Okay. Shortcuts and all we will do later. Okay. The way we have to think, full blasted view. So there is this mass which is coming down, and just before the collision, they say that the velocity was v. Okay. So this mass is also m, and this mass is also m, right?
Yes.
So let us write the momentum impulse funda for each of the strikes. Is that clear?
Yes,
Yes.
sir.
Each of the strike. Okay. So this is the example. Impulse study on each mass. What are the masses? There are three masses for us, right? Is that clear?
Yes, sir.
Yes.
So somebody tell me for this yellow mass M. What is it? I want what line? I want this line to be properly written. Impulse can be written as what?
Delta P.
I. You can say I or I1. Okay, you don't have to write. You can write delta P, your wish. Okay, I or delta P. I want just simply this line to be written.
So M1
So I'll give you some variables so that everybody is writing the same variable. Just after striking, it is said that the yellow mass sticks with the tray. So the tray and the yellow mass will be going with the same velocity down, right?
Yes.
Yeah. So let that be. Let after strike the velocity of the tray down is v. Is that clear?
Yes. So but
Now
it's,
write it. Now write it.
it's already going down with V.
Nothing is going down with v. The yellow mass is going down with v. Who is that?
Yeah. So we name the
Understand the question. There is the tray and the pink mass is not going anywhere. What
yes,
I'm saying, let the tray
So there are two variables called V.
acquire v velocity
So he's saying that the velocity of the yellow mass
mass
initially was already called
Was already called V.
Oh, I'm so sorry, man. Call it as U then. Okay. So that we have a U. Can we call it as U?
The initial mass, the initial velocity of the yellow mass is U.
Yeah. Yeah. I'm very sorry. Let the tray acquire a V velocity just after striking. Yeah. So who will write the impulse equation for M?
So for which app?
Yellow, yellow.
So you can add Vishwagna.
Huh?
So you can, it's Vishwagna, can I add?
Yeah. Tell M.
So M1 V1, which is
Not
0
M1. M it is of the yellow. Yeah.
into V1, which is 0.
V1 नहीं जो है जो दिया हुआ है वही आप बताओ. So that I do the question, not a theory.
Yes, sir. So
U was the velocity before striking. After striking, the tray and the mass will have V velocity. You tell me in those terms. Tell me.
Yes. MV
Yeah.
minus MU is
Okay.
equals MV equals MU minus delta V.
Hmm. Okay. Anybody else? See carefully. See carefully.
minus delta V.
So this is the mass. Okay. And it got an impulse this way, right, guys?
Yes.
Yeah, sure.
And the velocity became how much? Must have reduced and become V velocity, right?
Yeah.
Yeah.
So what is your MV?
MU minus I.
Yeah. MU minus I. Did you say the same thing, Vishwagna?
I think so, sir. I meant to.
Okay, I thought you said the ulta, but it's okay if you said the same thing. So MV is equal to MU minus it got a impulse, okay?
Yeah.
Right?
Yes,
Can
sir.
I call this impulse as I1 impulse?
Yes, sir.
Yes, sir.
That's my equation number 1 and my study of body 1 is done. We'll go to the next body. Okay, the easier body is the block hanging on the other side. So shall I go to that? That's
Yes.
quite easy.
Yes, sir.
Okay, I'll go to that and I'll say my second is on the block. Okay, I'm just drawing the block, my pink block. And what impulse is this block getting, guys?
I2.
I2.
tension.
Yeah, from the tension, it got a I2 impulse, right? What was the initial velocity? Nothing.
0.
And later it went where? Up. With how much of velocity?
V.
V. Okay, this can be a problem. Okay, we say the string is not extendable and the velocity remains V. This can be a problem. We'll debate someday else. Okay, but for JEE, we'll take it as V. Is that clear?
Yes, sir.
So if this side is going down with V, this side will definitely go up with V. So what is this impulse equation? We'll write somebody else this time. Abhinav, can you tell me the impulse equation now
So,
for this body?
so
Yeah.
one second.
Fatafat. So initially there was no momentum. It received a I2 impulse and the momentum became how much?
MV.
MV. So what's the equation we can write?
So 0 equals
Yeah, 0 equals?
MV plus delta V2.
No. I2 is equal to MV.
Yeah.
Yes,
Yeah.
Okay.
Initially.
See the
Yeah.
final momentum. What is the final momentum? We write like this. The final momentum is whatever was the initial, then what impact it received, right? I2 in the direction, right, of the final momentum. See how we have written. Final momentum is initial minus it was a negative impact. Final momentum is initial plus it was a positive impact, right?
Yeah. Then
So final momentum, like here also we wrote final momentum. In this also we wrote final momentum. And then is initial momentum and got a negative impact, the yellow body. So this is how you'll write. Is that clear, guys?
Yes.
Is that clear?
Yes.
Now who will tell for the tray?
Sir, can I try Ahan?
No, not Ahan, you have already answered. Mr. Either Avik or Abir, one of you, who will say?
I'll try. Sir, so,
One second. The tray, right?
yes, sir, yeah. Sir, so,
Yeah, initially zero velocity and finally the velocity is v going up, by the way. Yeah, tell me.
sir, so 2 MV.
2 MV. Why 2 MV?
Sir, because even the small one gets embedded into the pan.
Doesn't matter. We are studying just the tray.
Sir, so MV. Um, minus 0.
Not
Yeah, sir.
MV minus 0. It's MV
Yeah.
came from where? From initial momentum, which was 0. Yeah, then?
Sir, 0 minus delta V.
No. There's so much I1, I2 written. You tell me in those terms what it is.
0 minus I1.
No, wrong. How can MV be a negative? I1 and I2 are all positive over here because I've written in the right directions. They're no longer vectors. They are vectors, but I've written with the direction, so they are values as such written because the direction is made. So this tray received two impulses, right? What two? One from striking of the body, and this is down. How much is that?
I1.
According to the action reaction, it has to be I1, right?
Yes, sir.
And the other one, and this is not, this impulse should have made the body go down, right?
Yes.
And it is going down. I just made ulta, I'm so sorry. V velocity down. Yeah. This impulse will make the body go down, right?
Yes.
But then the string is spoiling the case. It will not make it go as fast as it could have gone. The spring is having an impulse upwards, right?
Yes.
Yes.
How much is that?
I2.
I2.
So the string gives I2 impulse upwards, right?
Yeah.
So MV is acquired from the initial momentum, which was in this case nothing. It had no momentum. Should have got momentum from the I1 impact, but then I2 is killing the momentum a bit. And that's my equation number 3, right?
Yes.
Yeah.
Now writing all of it will give you a simple, what simple? MU is equal to MV plus MV plus MV, like 3 MV, stuff like that, right? But this is the full blasted view. Is that clear?
Yes.
Yes.
Yeah. So we'll replace the I1 and I2 values. Like equation number 1 and 3, if you add up, what do you end up with?
2MV equal to MU
MU
plus
minus
minus
I2. MU
Yeah,
minus
all three equations, if you add up, what do you end up with?
MV
Equation,
equals
all three you add up.
V equals MU.
Yeah.
1 plus 2 plus 3 gives you,
MV equals MU.
hey, do
3
properly,
MV
man.
equals MU. 3 MV equals MU.
Yeah.
3 MV equals MU.
So that gives me a 3mv equals to mu. So no wonder my v is equal to u by 3, right?
Yeah.
Right?
Yes. Yes.
You can always think of the whole situation as something like this. Everything flat. Pulley is just making the change of direction. Everything flat. A ball came, m mass came with u velocity and hit the tray, which was of m mass, and this is of m mass. So what's the initial momentum? mu is the initial momentum. What's the final momentum? This sticks to that. So all of them go with the v velocity after stacking. So it is m plus m plus m
Into V.
v, right?
Yeah.
Right. So alternatively, we could have done that way, but obviously we are in the learning stage right now. So we have to understand the impulse and we should be able to write the equations of the impulse correctly. Is that clear?
Yes.
Yes.
Yeah. End of lecture. I'll give you the homework.